This is a card whose mass is m and its initial velocity is 0 meter per second. And we are assuming that this force displacement graph is representing the motion of this card. And we see according to this graph that the large force, a 20 Newton force, is exerted on this card, which is producing positive acceleration, and this card is gaining velocity in every next interval. Although force is decreasing, acceleration is decreasing, but acceleration is still positive, which means that the gain in velocity is positive. So in this question, you have to find out what will be the velocity after when it traveled 4 meter. So this is the total distance, that is 4 meters. And this is what you see the next position of this card with the passage of time. Okay, how can we find out the velocity? So for any graph, we always check the two things. The one is the slope or a gradient of that graph, and the second is the area under the graph. So slope or the gradient of this graph is not giving us any physical concept here, or it's not pointing towards any physical quantity. So that's why our next step is to know that what is, if we calculate this area, does it give us any meaningful physical quantity or not. So dear students, the area under this straight line or any force displacement graph is always equals to the work done by a force. All right, and you can also check from the units if you calculate the area. So while calculating area, you have to multiply Newton with meter, that is equivalent to joule. So this is a work done, and this work done is positive because this area is positive, and we know that the positive work done always points towards the gain in energy. And why I'm saying gain in energy, because we see, as I told you, that the change in velocity was positive, acceleration is positive, so it is gaining velocity, and we have to calculate the velocity at this moment. So this work done is equals to change in kinetic energy. It's not change in potential energy because it is traveling on a horizontal surface. So that is equals to 1 over 2 mv square minus 1 over 2 mu square. Don't you think this is 0 because it started from rest? And if we calculate the area, and by the way, this area is 1 over 2 into base, which is 4 meters, into height, that is, in fact, it is 16 newtons. I mistakenly said 20, but it is 16 newtons. All right. So that is equals to 1 over 2, mass is 4 kilogram into v square. So now you have to just solve it, and it will become 32 joules is equals to 2v square, and v square is equals to 16, and if you take the square root, then it will be 4 meter per second. So dear students, this is a velocity of this card. If we apply this graph for the card, so it will be 4 meter per second. So the right answer is option B.